Hello everyone, today in this video we are going to talk about acceleration. So after this video you should be able to define acceleration and derive and apply the formula of acceleration. So to understand the acceleration, let's see the ABC of a car. So A is for accelerator, B is for brake and C is for clutch. And if you don't know what are these things, I think this picture will make it clear. So when you press this accelerator, this will happen, and when you press the brake, this will happen. So accelerator increases the speed and brake decreases the speed. So this acceleration and accelerator is somewhat similar. So from here we have understood that acceleration means increase in speed, but the actual definition of acceleration is rate of change of velocity with time. So it is not only increasing, it can decrease also. So acceleration is denoted by A and the unit of acceleration is meter per second square. So if the object is accelerating at the rate of 1 meter per second square, that means its velocity is increased by 1 meter per second. So in this picture you can see the acceleration of car is 1 meter per second square. So when the time is 0 second, the speed is 1 meter per second, and after 2 seconds it is increased by 1, that is 2 meter per second, and after 2 seconds it's 3 meter per second, and after 3 seconds it's 4 meter per second. So every 1 second the speed is increased by 1 meter per second. And in another example, at 0 second the speed is 7 meter per second and the acceleration is 5 meter per second square. That means every 1 second the speed is increased by 5 meter per second. So out here is plus 5 at 3 second, it is 22 meter per second. So acceleration gives us the idea how fast is the speed increasing. So this is the formula for acceleration. A is equal to V minus U by T. So V minus U means change in speed, V is the final speed and U is the initial speed by T, or we can say it to be speed or velocity as we are talking about motion in a straight line. So acceleration is a vector quantity, that means it has both magnitude and direction. To find the average acceleration, we find change in speed by change in time, or change in velocity by change in time. So out here delta V is V2 minus V1, change in velocity, and T2 minus T1 is change in time. And to get the instantaneous acceleration, that means if you want to know the acceleration at a particular time, that time you have to make this delta T very small. So we are putting limit to delta T, that time we have to differentiate, because when you make something very small, that time it becomes differentiation. This is the graph for zero acceleration, meaning the object is not changing its velocity, so it's a uniform motion. And out here it's a uniform acceleration, that means acceleration is constant and it is not changing, it is having same value everywhere. And this is uniform retardation, that means speed is decreasing but it is decreasing uniformly, so everywhere acceleration will be same. And this is non-uniform acceleration. Out here you can see velocity increases non-linearly. So now let's see what do we get from the slope of velocity time graph. So out here along y-axis is the velocity and along x-axis is the time. If we consider time from 2 seconds to 4 seconds, then we can draw lines to know the respective velocities. From here to here is change in velocity, and from here to here is change in time. So change in time is 4 minus 2, that is 2 seconds, and change in velocity is 20 meter per second. So for this triangle the slope is perpendicular by base. Perpendicular is change in velocity and this is change in time. So but we know change in velocity by change in time is acceleration. So acceleration is 20 divided by 2, that is 10 meter per second squared. So we get the acceleration from the slope of velocity time graph. To find the instantaneous acceleration, we have to make this time very small, so we have to bring this 2 points very near. That time we have to differentiate, and when we differentiate a function we get tangent. So that means when we find the tangent to the curve, that time we are finding the instantaneous acceleration. So to find the instantaneous acceleration we have to find the tangent. To get the average acceleration we have to find the slope. So slope of velocity time graph gives average acceleration, and tangent to velocity time graph gives instantaneous acceleration. So this is the formula for acceleration. Suppose initial and final velocity is same, that means speed is not changing. That time v and u are equal, that time a becomes 0, and that time the acceleration is also 0. And when the final speed is more than the initial speed, that time a will become positive because v is more, u is small. That time you'll get a positive number in the numerator, so acceleration will be positive. So if the speed is increasing, the acceleration will be positive. And if the speed is decreasing, that means initial speed is more, final speed is less, that time v will be less, u will be more, so that means negative is more. That time you will get negative value for the acceleration, and that negative value for acceleration we called retardation or deceleration. There are several ways to accelerate an object. Acceleration does not mean only increase of speed, it can be decrease of speed as well. So as we all know, acceleration is a vector, that means it has both magnitude and direction. So in order to change the acceleration, either we can change the magnitude or we can change the direction also. So there are three ways. So first way is we can speed up the object to accelerate it, and we can even slow down the object to accelerate, and even we can change the direction of motion without changing the speed. That time also we call it accelerated motion. Uniform circular motion. So out here you can see this ball is moving in a circular path with constant speed. The speed is not increasing or decreasing. That means its motion is uniform motion. So uniform motion is motion in which an object moves in a circular path with constant speed. Speed do not change. But out here we are saying speed does not change, but still this motion is considered as accelerated motion. Now if you see this diagram, the direction of velocity, it will keep on changing with path. So the direction of motion of object is changing at every point of the path, but speed is not changing. So but we already know by changing the direction of motion also we can accelerate an object. So uniform circular motion is considered as accelerated motion because direction of motion changes at every point of the path, so it is an accelerated motion, but speed is not changing out here. Acceleration due to gravity. So when an object accelerates due to the gravitational force of the earth, that time we call it acceleration due to gravity. So out here you can see at first this elephant is at rest, so afterward it will fall and the speed increases. It increases from 0 to some value, so that means the speed changing means it's a acceleration. So for earth, the value of acceleration due to gravity near the surface is 9.8 meter per second. Suppose the object is at rest when time is 0 seconds. So after you leave this ball, after 1 second the speed will become 9.8 meter per second. So after 2 seconds it will again increase by 9.8, so 2 times 9.8. So in similar way the speed keep on increasing, so that's why it's an accelerated motion. An object is thrown vertically upward with the speed of 49 meter per second. So how long does it take to reach the maximum height? So as we all know, when we throw something upward, it will reach the maximum height and it will stop for some time and it will fall down. At the maximum height, the velocity becomes 0, but acceleration is not 0. It is 9.8 because acceleration due to gravity is a constant. So at maximum height, velocity becomes 0 and initial velocity u is 49 meter per second, the speed with which we are throwing it, and acceleration is minus 9.8 because the speed of the ball is decreasing when it is going upward. So I'll put the value and time is 5 seconds. So after 5 seconds it will reach its maximum height. So when we differentiate the position with respect to time, we get velocity, and integration and differentiation are opposite. That means if we integrate the velocity, we should get displacement. And next, differentiation of velocity is acceleration. So that means integration of acceleration gives velocity. So out here, acceleration is differentiation of velocity, but we know velocity is differentiation of x. So for v, we can write ddt of x. So now we get double differentiation of x. So if you differentiate the displacement 2 times, you will get the acceleration. So d square dt square means double differentiation of displacement. So now we'll solve one question. So motion of a stone is given by x is equal to 3t cube minus 4t square plus 1, and t is time in second and x is in meter. So we have to find the position, velocity and acceleration of this particle after 1 second, and we have to find the time at which instantaneous velocity is 0. So object is at rest. So this is the position, and we know velocity is differentiation of position with respect to time. So if you differentiate this, so differentiation of t cube is 3t square and differentiation of t square is 2t, and differentiation of 1 is 0 because it's a constant. So the velocity is 9t square minus 8t, and acceleration is differentiation of velocity with respect to time. So this is the velocity, so I'll differentiate it again. Displacement, so we have differentiated it once out here, now again we are differentiating. So differentiation of t square is 2t and differentiation of t is 1. 8 and 9 is constant, so acceleration is 18t minus 8. So next, now we'll find the position. So this is the expression for the position, so we have to put time is equal to 1 second, then we'll get the position after 1 second. So if you put 1, then you'll get 0 meter. So at 1 second the position is 0 meter. And velocity, so if you put 1 for t out here, then you'll get 9 square into 8 into 1, that means 1 meter per second is the velocity after 1 second. And acceleration, this is the expression for acceleration, so 18t minus t. So if you put t is equal to 1, that is 18 minus 8, so 10 meter per second square. So displacement is 0 meter, velocity is 1 meter per second, and acceleration is 1 meter per second square. And we have to find the time at which instantaneous speed is 0. So instantaneous speed is given by this expression, and instantaneous speed is 0, so we'll put 0 for the velocity. So you take this 9 this side and you solve this, you'll get time is equal to 8 by 9 seconds. So after 8 by 9 seconds the velocity will be 0. So you can try this question in the similar way that we have done the previous question. And now this question. Now the acceleration is given by 2t minus 1 meter per second square, time is in second, and at time 0 second velocity is 1 meter per second and position is 0.5 meter. So we have to find the expression for velocity and displacement. So acceleration acceleration is 2t minus 1, and we know differentiation of velocity is acceleration. That means integration of acceleration will give velocity. So now I'll put the value. So now we know integration of t is t to the power 1 plus 1 divided by 1 plus 1, so t square by 2, and integration of constant is t, so that means minus t plus c is the constant of integration. This is the expression of velocity, but we have to find the value of c, and out here the initial points are given. When time is 0, velocity is 1 meter per second, so I can put t is equal to 0, velocity is equal to 1 in this expression. So if you put this, you'll get c is equal to 1. Then again I'll put the value of c out here. So we got the expression for velocity. Now if you integrate velocity, you will get displacement. So displacement is integration of velocity. So I'll put the value out here. So integration of t square is t cube by 3, and integration of t is t square by 1, and integration of 1 is t, and c is the integration constant. So again I'll find the value of c. So at t is equal to 0, position is 0.5. so if you put t is equal to 0, then you will get this. So now I'll put the value of c back to the equation. Then we got the displacement. So this is the expression for velocity, and this is the expression for displacement. So you can try this question the similar way we have done the previous question. And this is the end of the video. Don't forget to like the video and subscribe the channel. Thank you.